Copeland, John.
Oh, yeah. Okay. All right. Nice.
Alan Smith.
This is where we were sitting.
Lillian.
He's not leaving today. He's not leaving today. Miss.
Aaron.
Sis.
All right, guys. I need you to get out number 42 from Tuesday. That would have been the 4.7 book assignment. I think we started on that on Tuesday with about, 20 minutes left in class. So you only got a little bit of that done. That's going to be the main thing to get through today. But I want to go ahead and give some directions here before I give you time to work on that. Okay, so this will be our third class period that we have looked at, practiced, asked questions about section 4.7. So our next class, which is tomorrow, because it's a B week, will be our 4.7 quiz. I can tell you up front that your 4.7 quiz looks the most like worksheet 1 or worksheet 2. It's not exactly a practice quiz. It doesn't look exactly like that. But we will ask you that chart where you need to tell us the domain and range of all 6 inverse trig functions. Those are worth half a point each on the quiz, so that's 6 points you can get just from memorizing those. And of course, if you mismemorize the ranges, that can domino and make you miss a lot of other stuff too. And then there'll be a handful of questions like number 2 on worksheets 1 and 2, where you have to do some inverse trig unit circle questions and some inverse trig sketch a triangle type questions. So the book assignment is obviously a little bit more practice. So as we've done in the past here, I'm going to take your immediate questions that you have ready to go. Since you started on this last time, you may have a couple questions ready to go. Otherwise, I will interrupt every 10 to 15 minutes to give you a chance to ask for some of these work out of the work. This is one of the assignments I'm asking you to turn in before the quiz. So if you finish it in class, you should go ahead and check out Google Classroom and see what needs to be turned in. And then finally, last piece of information before I can start to take these questions. Your handout today is number 43. This is 4.7 worksheet 3. And this has been on my website as optional additional practice if you need it. But I felt like printing it out just because I know in this section, sometimes it takes more practice than others before you feel comfortable. So the number 43 though is completely optional. If you just want to practice a couple questions on it, fine. If you want to practice the whole thing, great. If you feel like you're solid after worksheet 1, worksheet 2, and the book assignment, that's great too. But if you do all of worksheet 3 and you turn it in before the quiz tomorrow, I will give you a homework grade. So if you choose not to finish it or you choose not to do it at all, you'll get an X in the grade book, and so X doesn't help or hurt you. But a little tiny incentive, if you know you need extra practice, you can get some extra practice and an extra homework grade. Okay, so before I start taking math questions, do you guys have any questions about tomorrow with the quiz, or what you need to turn in, or if you have to do this worksheet 3, any of the agenda type questions? Yeah.
Will the quiz be all class?
No.
Alright, so we're gonna go after the quiz, we're gonna go into 4.8.
Correct. The quiz is roughly the same length as worksheet 1 or worksheet 2. So if at some point, I mean, everybody works faster than or slower than others, but 90 minutes for that, you're not at the level where you need to be if it takes you 90 minutes. So. And remember, something else to keep in mind, I'm glad you said that. Remember, this unit has 2 sections only, 4.7 and 4.8. We will look at 4.8 after the quiz tomorrow, but it is almost entirely finding sides of right triangles with Pythagorean theorem and SOHCAHTOA, what you've been doing, and finding angles of right triangles by subtracting 2 from 180, or inverse SOHCAHTOA, what you've also been doing for a while. So there's not much new in 4.8. Most people think 4.8 is pretty easy. And 4.7, uh, 4.7 is definitely the harder part. So I'm just reminding you of that because this is a little bit more of a hurdle, but if you prepare well for tomorrow's quiz, then you are probably a lot closer to being prepared for your third test than you realize. So, okay, since I let you start on the 4.7 assignment last time, you guys may have a question or two ready to go. So I'd like to start off with those because there's no reason to wait. So, does anybody have any book questions that you know you would like to talk about? Yeah.
I have a question about the quiz tomorrow.
Okay.
Is it, like, are we able to use calculators?
It has calculator type questions on it, but it's no calculator. So, we make those, like we've done in the past, we make a multiple choice and you just pick the one that matches like how you would do it in the calculator. Not a ton of calculator type questions, but there are a couple. And it will be no calculator. Okay, anything from the book assignment that you have ready to ask?
How would we answer some of the questions on the book assignment? There's, I guess it's using the calculators and the inverse trig functions. How would we answer some of those without a calculator? Just kind of
Okay, well, pick
estimate answer, or?
Pick one.
27. Well, I guess that one's kind of hard because that one's not. I got not possible in that one. So.
Okay.
25.
25. So if 25, if we want you to do this, and it's a calculator type question, it's going to be multiple choice, and you would pick out the answer that would. You might need to say that your calculator needs to be in radian mode. Because to use a calculator with inverse trig functions, you need to be in radian mode. And you probably you'll have to select what would go in the calculator. So you would pick the one that looks like that.
Gotcha.
Again, it's the exact same skill, it's just we're not letting you have the calculator, so you just tell us what goes in the calculator. But we make a multiple choice too. Yes, Jack?
So, on questions, so whenever it says arctangent,
Uh-huh.
can we just write our answer as tangent to the -1?
Yeah, those are exactly the same thing.
Alright, so you won't count off if it's like
Even right here, I just did, these are completely interchangeable. Arctangents, a little nicer, like if you had to like type up a question or type up an answer, arctangent's really easy because ARC versus finding this, you have to, you know, search for exponents and it's a little harder to do. But these mean the exact same thing. So no, you would not be counting. Number 13, sure. Okay, 13 wants to know what is inverse tangent of negative square root of 3. So this question, there is a longer way to do this and a shorter way to do this. So let me start off with the longer way. First off, it certainly helps if you guys realize that inverse functions, the input is a ratio, the output is an angle in radians. So if your answer is not an angle in radians, like pi over 4, negative pi over 6, something like that, then that can't be correct. But this is asking what angle has a tangent of this within the range of inverse tangent. So the long way would do this would be if you don't memorize the tangent values, because when we memorize the unit circle, we really memorize sine and cosine values. So I guess you could think of the all students take calculus to realize that tangent's never going to be negative in quadrants 1 or 3. And then if you don't have these other spots memorized, you might pick a spot in the middle, do sine divided by cosine, because that's how we do tangent, and you would get -1, which is not what you want. Then you could try something else, like maybe right here, and you would get negative square root of 3 over 3, which is also not what I want for this question. And then finally you could pick this spot and this spot, and then when you do sine divided by cosine here, you get what you want. So the guess and check, sine divided by cosine, sine divided by cosine, sine divided by cosine, until you stumble upon the two places where tangent is negative square root of 3. Now one nice thing is at least tangent values are the same directly across. So as soon as you find this one, you know this one as well. But then you need to draw in the range of inverse tangent. Inverse tangent range looks like this. So I know the answer doesn't come from here, it comes from here, and your answer has to be within the range. That's why it's so important that you memorize those. So don't call this spot 5 pi over 3, you need to call it negative pi over 3. That's an angle and it's in terms of radians. That type of answer makes sense. You can save a lot of that time though. The shorter version is if you just memorize in the middle of each quadrant is either 1 or -1. By the x-axis is square root of 3 over 3 or negative square root of 3 over 3, depending on the quadrant. And the ones by the y-axis are square root of 3 or negative square root of 3. You can go straight to these two locations, and then after that it should be the same. Here's the range of inverse tangent, here's my answer, and make sure you name it within the range of inverse tangent. So I think you guys should memorize the tangent values, but you don't really have to, because you can always do sine divided by cosine. But in the long run, you're going to do more work than just memorizing it. Okay, so this first timer, I'll do just a quick 10 minutes. So try to get a couple questions done in 10 minutes. And if you get stuck on one, just go ahead and skip it temporarily and be ready to ask. And then when that timer's up, I'll bug you for some questions up on the board. Hopefully help out with a few things. And then we will just rinse and repeat until we run out of time. I just took questions. We should have done this last time. What angle has a sine of 1/2 within the range of inverse sine?
6. However, inverse sine is sine.
the same thing. Look at your notes. The very first thing we talked about in your notes is that arc sign is the same thing as the sign with the negative sign. So it's the same question. 5 or 6 is your answer. And you can see they just switch these up casually. Sometimes they say arc, sometimes they do the -1 exponent, but it's the same stuff.
The 47. I looked at, I did it and then I looked at the answer and said no. Cosine of arc cosine -33.
Sure they said not possible? Oh, you know what it is? It's the domain of inverse cosine is -1 to 1. And square root of 3 is, or negative square root of 3 is a little bit bigger than 1 and a little bit smaller than -1. So it's not in the domain, that's why it doesn't make sense. When you sketch, so since this is not a ratio on the unit circle, you would need to draw a triangle. But if you're paying attention, your hypotenuse would be smaller than that square root of 3, and that's why.
Is it over 11 possible to find something?
Number 11.
Yeah, no, it's not possible. The domain of sign is -1 to 1, so you can't use inverse sign for something that you're not. Okay, they want you to just start with the regular equation.
What?
Say
Are you gonna throw it in?
tan theta equals x over 4.
Did he already ask you?
So start with that. But then they want you to switch it from tan theta equals to theta equals. So your theta equals would be inverse tangent of x over 4. That's all they want. Inverse tangent of x over 4. Because you're saying the angle, this angle is the angle that has a tangent of x over 4, because it's opposite to its adjacent of x over 4. And that's what they mean by, right, theta as a function of x. So they want to know theta is equal to what in terms of x. Perfect. Okay, so it's only been 10 minutes, so I know you've only had time to do a couple more, but hopefully someone has found a few that I could help with. So if you've got any, let me know what they are.
Did you do a 39?
Number 39. Okay, make sure you guys don't need help with 39 before you continue with the one that you're on. Again, I don't mind how many or what questions y'all ask, but I don't want to do the same ones multiple times. This one says, use an inverse trig function to write theta as a function of x. So they want to know what theta equals in terms of x. So there should be some x's over here. So from theta, we know something about the opposite and the adjacent. So you could say the tangent, if I look from this angle, is opposite over adjacent. But they don't want to know what tangent theta is. They want to know what theta is. So to go from tangent theta equals to just theta equals, what?
Is that a 4 or a 1?
It's the same as that's in the book. It's a 4. To go from tangent theta equals to just theta equals, you're going to do inverse tangent. So that's what theta is equal to in terms of x. It has x's in it. If you want to find a side length, you would use regular sine, cosine, tangent. If you want angles, you do inverse sine, inverse cosine, inverse tangent. Yes? Okay, where is tangent square root of 3 over 3?
30 degrees.
I'm asking Jonathan.
I don't know where tangent. I don't know where that.
Well, I mean, if I just, well, I can tell you, but I don't know how that's going to help you because this is like the 50th time this year. You've got to try a spot, try sine divided by cosine. Is sine divided by cosine going to give you that?
No, it's not.
That's going to give you 1. You could try this spot. Out to the side, you'd have to do sine divided by cosine. Is that going to give you what you want?
No, it's not.
Okay, so then you got to try something else. This is why I said it might be worth memorizing the tangent value so you don't have to waste so much time here. Now, sine divided by cosine looks like this. But when you rationalize it, it looks correct. So here's one place where tangent is the correct value. And even though tangent values are more of a pain, at least you know directly across has the same tangent value. But inverse tangent exists from negative pi over 2 to positive pi over 2. So your answer is going to come from that spot, which we would call what?
30.
Okay, but inverse trig only exists in radians.
So pi over 6.
Pi over 6. That's it.
Okay, thank you.
The hardest part is dealing with the tangent, and that's why I recommend you memorize those values. There's only 3 of them, so. Okay, ready?
Can you do 45?
Number 45. Let's see, what is the sine of the inverse sine of 0.3? Well, first off, I don't want to deal with the decimal, so I'm going to change this to a fraction. This is like 3 over 10. 3 over 10 does not sound like a ratio I memorize on the unit circle. So that means if it's not unit circle, it's going to be sketch a triangle. Inverse sine needs to be in quadrants 1 or 4 because that's the only quadrants the inverse sine cares about. We're going to draw our triangle in quadrant 1 if it's something positive, quadrant 4 if it's something negative, because in quadrant 1 sine values are positive, quadrant 4 sine values are negative. Bless you. Okay, and then sine is opposite over hypotenuse. So it's fine to take a couple minutes to do each question, of course, But the part that you guys should not be slowing down on is if this isn't unit circle, you have to sketch a triangle. It doesn't mean your triangle is sketched instantly, but you should know to sketch a triangle instantly. Now, most of the time, I have to do Pythagorean theorem to find this side. But in this question, it's just turning around and saying, well, what's the sine of this angle? Well, sine is opposite over hypotenuse. So your answer is 3/10. Or 0.3 if you want it as a decimal. And you should not be trying to learn any shortcuts like that, but this question should kind of make sense. It's saying, what's the sine of an angle that has a sine of 3/10? Well, the sine of an angle that has a sine of 3/10 is going to be 3/10. That's why that just basically ended it. But if you just always assume these are going to cancel out, you're going to miss some stuff. It depends on what type of things on the outside, a regular trig function or an inverse trig function. It depends on what type of angle it has, whether these just cancel each other out. You should still work it out the long way. Was that enough, Madeline? Okay. Somebody else had one. Okay, I guess that was the same one. Okay, let me give you another 10 minutes here. So try to get a few more done in the next 10 minutes, please. Again, those of you that got more done last time and are closer to being finished, you should probably go turn your stuff into Google Classroom when you're done, so you don't forget. How about y'all?
We're doing good.
The picture's so dark.
Yeah.
There's no chance that's possible because in quadrant one, tangent's positive.
Right, so.
Where is tangent negative square root of 3? Where are the two times on the unit circle that tangent's negative square root of 3? Tangent's positive in quadrant 3, so there's no chance that's right. It's got to be in quadrant 2 and 4, yes. But which spots in 2 and 4? You can, or you can memorize the tangent values. It's not that hard to memorize the tangent values. If it's near the y-axis, the spots near the y-axis, it's either square root of 3 or negative square root of 3, depending on the quadrant. If it's near the x-axis, they're smaller because they're being divided by 3. But in quadrant 2 and 4, tangent's negative. And in the middle of each quadrant, sine and cosine are either the exact same thing, or one's positive and one's negative. Those are the only tangent values. So you're going to save yourself a whole lot of time if you just know it's here and here. Your question was inverse tangent, so you want this spot, negative pi over 3. Done.
Let's see. A couple of questions. What about 47 right here? Wasn't quite sure. So it's cosine of square root of 3. What was the value for it? It was a square root of 32. So I did a strong triangle. Square root, I did square root of 3 on the adjacent side. Just did over 1 to make it a fraction. I just did the hypotenuse. Wasn't quite sure.
It all sounds good, but when you go to check your answer, the thing that's kind of hard to see here, and honestly, I didn't think of this a second ago, but you don't ask me. Square root of 3 or negative square root of 3 doesn't matter. It's a little bit bigger than 1.
Gotcha.
So that's not in the domain, so it's not going to work. And then with your picture, it's hard to see, but that's bigger than 1, and that can't be bigger than 1
Yeah.
because the hypotenuse is supposed to be the bigger side.
Gotcha.
So that one's not possible.
Gotcha.
That's kind of tricky though, because if you don't know what square root of 3 is, it's a bit hard, that's why it doesn't make sense.
This doesn't
Only art cotangent. The others work out just fine. But inverse cotangent is something that you have to add to your answer. Just cotangent is something negative. Inverse cotangent is something positive. It's not possible. You have the bookwork, Karen? You finished the bookwork?
It's still getting memorized or anything.
That looks good. I'm just making sure that you have that done. Because this was the optional one. If you finish it, I'll give you an extra homework grade, but it's worksheet 3, right? And there's the optional. triangle out of that guy. Opposite is 5, hypotenuse is 13. Sine. Is your wallet in from this? Yeah, like that. Plus then if you ever lose it, it's extra bad. So yeah, he's got sine, so good. And then now you want to know secant better. So secant is going to be hypotenuse, which you have, over adjacent, which you don't have, but you can get it like that. And then you should be done.
Where did you get a
For that section. So it's a one level. Thanks a lot.
Oh, wow. That was a fast 10 minutes, but our 10-minute timer did end, so you guys have a few more to talk about on the board? Yes, sir.
63.
Question 63. Again, I know a lot of you guys are not that far through the assignment, but you need to at least glance at it and see if it's one you need help with. If it looks fine, go ahead and go back to what you're doing. But okay, so when I look at 63, I want to think of this as a ratio, so I'm going to put this over 1. And this is not any of the ratios we memorize on the unit circle. So with about 5 seconds of thought, I know I have to sketch a triangle here. Inverse sine only cares about quadrants 1 and 4, so I know my triangle has to be drawn in quadrant 1 or quadrant 4. I'm going to draw it in quadrant 1 if it's inverse sine of something positive, because sine values are positive in quadrant 1, and I would sketch my triangle in quadrant 4 if it was inverse sine of something negative, because sine values are negative in quadrant 4. This is a positive 2x, so I'm going to sketch it in quadrant 1. Then, SOHCAHTOA number 1, label your opposite and your hypotenuse, because they gave you sine. Then most of the time you need this third side, so do Pythagorean theorem. I know you guys feel like you're experts at Pythagorean theorem at this point, but sometimes you do go too quickly or do too much of it in your head, so make sure you get that down right. And now, this stuff in the middle of the question is this angle. This is an angle that has a sine of 2x. The question wants you to answer what's the cosine of that angle. So now that I have the other side as well, cosine wants me to pair up adjacent over hypotenuse. So that would look like this or this. Okay, anybody have anything more detailed about 63 before it goes away? Okay. Other book questions you have ready to go? Okay. Then let me give you a few more minutes to work. What do you need? Nope. I don't think I have any. I'll look. You get stuff turned into Google Classroom. And you don't need a study for the quiz.
I do the worksheet, probably did like in invite you before the quiz.
Just that I won't be able to help you if you do it that way, but that's fine. You're gonna hurt yourself. Make sure you memorize those too. Remember how to find those? Because you should have them memorized from the last unit. The domain of the inverse functions is the same as the range of the regular functions. So, if you remember the range of sine, the range of regular cosine.
How do you tell which quadrant the triangle is?
It's gotta be in a quadrant that exists for that inverse trig function.
Oh, okay.
So like if it's inverse tangent, it has to be quadrants 1 or 4. And one quadrant tangent's positive, quadrant 4 tangent's negative. So if it's inverse tangent of something positive, draw in quadrant 1, inverse tangent of something negative, draw in quadrant 2.
Yeah. Proven facts. Did you know it's proven facts? It is facts.
You're not wrong.
I mean, he's very right. They got stamina, they've got
Yeah.
You agree with proven facts already.
No, that's a recording.
What? No, you're not doing recording. I think it's a proven fact. Do you think it's a proven fact?
Anybody taking the ACT this Saturday? I have to try to remember to ask you what kind of trig is on there. Should be two SOHCAHTOA, but then the other two are up in the air. Hopefully it's a sine or cosine graph, since we've done that recently, and sometimes this stuff too. But usually really easy ones if it's this stuff.
I feel like one of them is always like a triangle. With a bunch of like, the answers are just crazy long. Cosine, sine, tangent.
That might be law of sines and law of cosines.
Yeah, there you go. That's what it is.
We do that in January.
Really?
Unfortunately, that doesn't help with calculus, but since it shows up on ACT option, we do. We only spend like 2 classes and then
Yeah.
it's pretty easy, but
Really?
well, okay, so that looks like a ratio on the circle, but for tangent, that's not.
I would think no, it's like one of the very nice things. But it like you go ahead and can you send this?
You see anything wrong with this? So you realize how that's more that doesn't make sense. The other way is you could catch that before you even got here, is the domain of inverse cosine is negative 1 to 1.
She didn't say that.
So there's no way to do that. Solid.
He says numbers and
Yes.
Make sure you know.
Send me, actually. This is fine. Pretty good.
You all done? All done?
Do what? Oh my god, what? Why do I have the shortest memory?
He was on.
I'm sorry. Oh my god, one's
I
frozen.
might try one of the tech office. They
I'd be
might.
looking like that boy scared. No, Catherine, come on.
We
Did
went
you
over
see
this
that
one.
picture of Caroline? That was her, I think by this week, her coming in, oh, didn't even look like I felt around. My face was so warm.
Okay, I know you guys were running a little bit lower on questions, but it has been about 12 minutes since I gave you a chance. So, has somebody found some more I can help with out of the textbook? Okay. Yes.
I was just looking at the extra problems.
Uh-huh.
How would arc sine 0 work?
Arc sine of 0. Where on the unit circle is sine 0?
It's the origin.
Huh?
The origin.
No, I'm talking about where on the unit circle.
Oh.
The origin's here.
At x equals pi over 2. Or not 2 pi.
Okay, all the way around, sure. Or 0 has a sign of 0. Where else is there one?
Pi.
Okay, so there's the 2 places where sine is 0. What's the range of inverse sine?
Negative pi over 2 over pi over 2.
Okay, so your answer is going to come from here, not here. And what do we call that angle?
0.
Which your answer. At 0 radians, sine is 0. Now, of course, as you guys have started to finish up worksheet 1, worksheet 2, book assignment, maybe the optional worksheet, you're going to have a real good idea of what's holding you back. If you're making mistakes from not memorizing the ranges, or you get that wrong sometime, force yourself to write it on a piece of paper, check it with your notes. Write it on a piece of paper, check it with your notes. Write it on a piece of paper, check it with your notes. That shouldn't be an issue if you really know those ranges. Likewise, if it's unit circle problems, on a blank piece of paper, draw a unit circle, label all the points, check them with your notes or from Google. Do it again, check it, do it again, check it. If that's what's holding you back the most, and that's specifically what you need more practice on, then get the more practice. So we're still going to be using unit circle the rest of the semester. But in this section, if you don't know the unit circle, the questions go from challenging to pretty much impossible. So. Okay, that bell tells us you've got 30 minutes left. So seems like you guys are running a little low on questions, so I'll stop bugging you every 10 minutes, but 30 minutes is still a lot of time. So if you need some help, you need to either call me over to your desk to help you or bring it up here so I can help you. And if you're finished, please turn those things into Google Classroom so you don't run the risk of losing them or forgetting them tomorrow.